Hi everyone, hello from Lithuania. My Russian is a bit rusty, but I'll try to. I'm sorry in advance, but I'll try to as best as I can. So ISO IEC 81346, International BIM Language on the example of the shopping center in Vilnius. There's a shopping center in Vilnius, around 100,000 square meters. In 2015, BIM project was launched, a pilot project. Our company was engaged to help preparing all the documentation, and last month it was officially opened, March 2018. I would like to show you a video with a BIM project plan, and I'd like to draw your attention to the fact that already back then the classification of certain data started. So BIM users, for instance. And also some areas were identified for real estate developer that were of interest for the real estate developer. This is BIM users classification, geometry classification, LOD classification, and what's very important here is parameter classification. So BIM users would like this to have all the parameters. It was very important for them. We did it ourselves, all the parameters, so it's custom built for one project. I'll show you how we did it later on. So the entire classification is here. Geometry, all the requirements. This is the plan. All the construction components are here, and all the parameters that we are interested at some drop points. Cost estimation, facility management, etc. We got a response from the designers. After several months, they prepared the responsibility matrix, again with all the components that I mentioned before, and at the top all the parameters in the matrix, and all the responsibilities are in the matrix. Who is going to be responsible for this parameter? Who is going to fill it in? Around 300 lines here. And our lot, of course, what we expect from the designers, our technical expectations. Designers said that we need a very clear marking classification for each element. Next video. So this is how they did it. Nobody understands how they did it, but we used Lithuanian letters, but so it's impossible for you to understand anything. Well, it's impossible to me for me to understand anything either. So each component is here with a marking, and using this marking you can filter the components, filter it out. So, single information model. How does it look like? What do we have as a result? So this is the file structure here. The entire model was done in Revit. Navisworks was responsible for this navigation. All the navigation was done in Navisworks. It's a decent 3D model, but it does have some flaws in it. But they were not crucial, and the construction phase already began, so we didn't have time to fix everything. So as soon as we got the 3D model, we started data preparation during the operation stage. And we saw that the data structure does not fit for data management. It's not suitable for it. Revit has its own data structure. Unfortunately, you cannot see it here. But the principle is when we export it from the Revit, you get the tree with the layers, with the components, based on the types. And if you in Navisworks, if you import the AFC file into Navisworks, you will have a completely different picture. So we had issues with parameters and with their structure. So navigation was very complicated. It was very hard to navigate. During a discussion with the client, we decided to implement the ISO standard to fix all the mistakes of the designers and in order to improve the navigation with the fixed components. This is an updated slide. What was important for us was part 2 and part 12, which contain the classification, how to classify a system and how to classify the parameters of the system. It's like an international language. It's like the notes for the musicians. Everybody understands and reads those notes if you know how to do this. So the principle is very simple. The standard has a systemic approach and describes this systemic approach. And it includes different aspects. If we are interested in type-based components, where they are spatially, we can find it and we can do it. And this is the result, what we got. This video shows all the component classification, elements classification. So you see the classified tree, and you can navigate easily and find and pick what you need. For instance, even the logo, you can classify even the logo, all the signs. And if we're interested in construction elements, well, we can also choose some columns, foundations, and again we can classify even the parts of these elements. The frame, for instance. This is just a window frame. Bolts. No, it's very easy to navigate, very easy to use. And so all the details in one place. Walls, all the frame work, all the fittings, fixing elements, and the bolts. And it's very easy to export all the information into the specification. Just select what you need and export. Lighting, parking. Systems, BIM systems. This project was very interesting to work in, because when we started making the system trees for each component with its location and assignment, whom does it belong to. So this system tree was created like this, and again it is very easy to navigate through this system tree. For instance, if I'm interested in ACVC ventilation system, I can choose it, select it, and see it. Very easy. It's easy to identify some problematic area if something doesn't work properly, if something fails, breaks down, and we can even connect some sensors to this process train and to see it in real time what's going on. Heating, for instance. First part, second part, you see how it's very easy to filter out the components. And there's a dedicated tree for each room. This is how the tree looks like. And change colors also. So you don't need to make any complicated formulas for color coding. You have the system where all the elements are already color coded. So what's the benefits of this ISO standard? When we classify all the components, we generate a unique code for each component, and it stays forever for this component. We can change the properties, we can change the location, but the code stays forever. It's permanent. And another advantage is that everything can be coded. So this classifier covers not just the buildings, but also infrastructure facilities, railroads, bridges, whatever. And it's also good, and it's IT friendly. So the programmers can easily find the right component in the structure.
We very often hear a question on the quantitative analysis. So we can run this video and I can demonstrate it to you. Just a quick demonstration of how we can use the data from the classifier. So the classified systems include all the components, doors and other elements, and so we can move down the structure and get information and the result very quickly. So here we have the doors, the windows, the ventilation system. So we export all this and get it here. So it just took some moments, very quickly. And then we can filter the data. We can integrate the data using budgeting programs and automatically get a budget item sheet. Another challenge was about gathering data from the construction site. We developed the BMAX system and set up a connection between the BIM model and the construction site. Every component has its own code, and it is located somewhere inside the server, and it contains different parameters. You can connect declarations, documents, and tie them to dedicated elements. If you want to get a specific piece of information on the lighting in the parking lot, we have a dedicated link. We can click the link, and each lamp has its own code, and there is a connection to the server, so I can reach any documents I need. Thank you for this. The classification is pretty simple. We have a dedicated letter for functional systems and 2 letters for technical systems. We also use 3 letters for the components. So if I see these letters, I can understand what is meant. There are dedicated rules on how to generate codes for systems, for communications, for components. I will skip a few slides because I'm a bit pressed for time in my presentation, so just a few more quick and simple examples. We have a line created in AU, for example, and if I add a code there, so that means that you easily can understand that it's a pipe. I can add further codes, for example, the location code, and by this you will understand that it's located in shaft 1 to 3. Then another code will show you that this pipe is related to the lighting system. I can add and understand the information on properties. So 50 millimeters PVC materials, 205 meters long, and a 3-meter thickness of the wall. As for properties, there is Lithuania and Latvia, Denmark, Sweden, and Estonia. So these three countries already adopted the standard, while the others are currently adopting it. In Denmark, for example, this is already at the government level, and also in Sweden. This working group requests financing from the European Union. They want to have better harmonization on the name of parameters. This is their final objective, so that's it. Thank you. If you have a question, we will give you the mic. A couple of questions. I saw you showed us the Navis work practice in your company. I have some experience as well. In your resource, the tree is grouped, and you didn't use the selection sets. If you integrate some changes to the model, then the sampling can sometimes disappear. Yes, you're right. If we change anything to the model, you can create a search set, a search request, a search set of data. You created this model for a particular facility, so it cannot be used for a different facility, but it has already been commissioned. All the components are already integrated there, so there is no sense in further using this model. So how much time did it take for classifying? So it took us in Navis work about 2 weeks to classify all the components for one person. And you did the sampling of all the elements. Yes, it also was within this time frame. We have the question from the first row. Could you tell us, you told us that you drilled down the model down to the bolts. Isn't it excessive? We used a dedicated software tool for that. In BAP, we didn't indicate the requirement to provide a design and drilling down to bolts. In Sophistic and in Revit, it is possible, but we used the model that I just described. In the video, you showed us that your model includes external lamps. What program what software did you use to model the outdoor lamps? All these we did in Revit. We performed energy analysis, lighting analysis, sound analysis. We exported the model through EFC and other calculations and analytical software tools. Then we imported the data back and received the final result. One more question. In Russia, traditionally all the classifiers are influenced by the state standards, so-called GOST. The ISO is relevant for us in terms of electrical standards and other elements. So the question is about Lithuania. In Lithuania, did you have any complexities, any difficulties with the standards, the legacy standards from the Soviet Union? Did you face any difficulties when you switched to new approaches to classify elements and in switching to ISO standards completely? In Lithuania, we have budgeting classifications of accumulated data for components. In many companies that operate in Scandinavia, they use Omniclass, Uniclass, and we very often have many discrepancies. As for classification in Lithuania, we have a digital construction company that is responsible, that is focused on the BIM standards. I am responsible for the classification in Lithuania. Yesterday we got a message from our government that in 2021 there will be an official financial support of this process at the government level, so that we have such a standard at the level of the whole country. And the last question. So your role in this facility was about controlling on the side of the customer, so you were not involved and responsible for modeling. We are representing the developer in this project. So could you elaborate on how you controlled the quality of the model, how you tracked the model from designers? The BIM team had its own BIM coordinator. They performed all the checks before sending the model to the customer. From the customer, from a customer perspective, we analyzed and checked parameters. We didn't check the geometry. Very often we saw very strange parameters that are not relevant. So we found a number of discrepancies in altitudes, for example, and others. So this is a double check that was performed from two sides, and as a result we received a high quality model in terms of parameters. We used 3D scanning. We combined the real situation with the model. We made some corrections and adjustments to the 3D model during the construction process. This is it about the quality, probably. This is it to reply to your question. Thank you.